controversial. Um,
Does it involve Ukraine?
no, it does involve glucose, and one thing involves glucose, and the other thing involves. Have you ever heard of the Minnesota starvation study?
Yeah, really long time ago, right?
Well, guess who did that study?
Oh no.
Ansel Keys.
Oh, yes, that's right.
Well,
The history books.
Yeah. So, I mean, so he's the sinister guy behind why we took fat out of our food supply. But I think he's an even more sinister character if you look at the Minnesota starvation study. And so, but I'd love to, maybe just for you to start out and just kind of bring us up to date on what you've been looking at. I know you have some study results that,
Sure.
Maybe you want to share that, and maybe we can talk a little bit about some of the things we've been finding in Sugar Shift in our study, and then maybe talk a little bit about this glucose 101 in the work of Dr. David Stevens, and also, I think it connects into this Minnesota starvation study, and the fact that I think as a population we are suffering from high calorie malnutrition.
Mm-hmm. Hey, Maha.
Muted.
A lot of familiar faces here.
So we always have a nice attendance, especially when you come on of your super fans. But I do have a number of people in the Sugar Shift Challenge group who are big fans and followers of your approach, and have had great success with improving their health. And I'm always telling people about Super Gut. So.
Well, I can tell you about the little clinical trial. It's almost embarrassing, this little clinical trial, because it was meant to be a skin trial. So I talk a lot about Lactobacillus reuteri, as you know, because all the things we're seeing, all the things that we're seeing initially in mouse trials, this is usually not true, right? Stuff you see in mice often does not translate into humans. But everything they saw in these very elegant studies done at MIT about 8-9 years ago has held up, to my great shock, in humans. So we're seeing loss of skin wrinkles. The fine wrinkles like crow's feet and smile lines will disappear typically about 90 days. There's an increase in skin moisture, sebum. There's a return of youthful musculature. We don't talk about that. That's a huge advantage, to have youthful musculature. Especially in light of what people are doing with weight loss, like these GLP-1 agonists, where you lose huge amounts of muscle. Guess what? You do that, you die several years earlier. But I said again, you pay not you, but speaking in general, you pay $12,000 or whatever, $15,000 to lose 40 pounds, of which 10 pounds is muscle. You just shaved several years off your life. That data is quite confident, as well as accelerate your path to frailty, fractures, falls, and loss of independence. And so muscle preservation is very important. We get an increase in muscle. We get a return of youthful musculature when you get reuteri. There's an increase in testosterone in older guys, typically 50%. There's a return of vaginal moisture and sensation in older ladies. There's an amplification of the immune response. There's better sleep, deeper, more vivid dreams, like kid dreams. There's all the phenomena associated with oxytocin, like an increase in empathy, the intensity of love and affection for people close to you, desire for human connection, and my favorite, the acceptance of other people's opinions. So huge effect with reuteri. So I've been talking about it. But the ladies say this to me. Don't be insulted. Ladies all say, we don't care about that. We just want better skin. And I thought, what? Okay, fine. Let's do a little skin trial. So we had 25 ladies, no control group. We just asked them, don't change your diet, don't change your exercise program. Just get these 4 capsules per day. The capsules contained 40 billion counts of Lactobacillus rhodori, our strain. I threw in marine-sourced collagen peptides, hyaluronic acid, 2 things absent from the modern diet because we were told this idiotic message to cut dietary fat and cholesterol. So people abandon organ meats. We lead a collagen and hyaluronic acid poor diet now. Those are very important for skin. This was a skin trial, right? And I threw in astaxanthin, the carotenoid, because there's very good evidence that astaxanthin has very specific effects on skin. So we give these ladies these as 4 capsules, 90 days. We did tests like high-resolution skin ultrasound, and we did indeed record about a 15% increase in dermal thickness, which doesn't sound like a lot, except that the most ever achieved, to my knowledge, before, like with collagen, was 7%. So we doubled the increase in dermal collagen. Ladies were thrilled. They lost their wrinkles, right, over 90 days. But we happen to measure waist circumference. We don't have a pharma budget. We have to do what we can. So we measured waist circumference, and lo and behold, the ladies lost up to 8.5 inches off their waists and didn't lose much weight, maybe 1/3 of a pound tops on average. How can you lose up to 8.5 inches off your waist and not lose weight? Muscle. We didn't quantify muscle. It was a skin trial, but consistent with the animal evidence, consistent with our large anecdotal human evidence, consistent with my own personal experience, a huge return of youthful musculature and all the health and longevity advantages that brings with it. So we're about to start another trial. We're going to quantify formally amount of muscle and amount of abdominal fat lost, and it's a whole bunch of other biomarkers. But I'm seeing it play out. That's a great thing about what Martha and I are doing, and what you guys are doing, is we're playing this stuff out. We're learning lessons outside of clinical trials. Just by doing these things, we're learning lessons no one has ever described before. For instance, rhodori with deep sleep and vivid dreams, never described before. So our kind of crowdsourcing of wisdom, we're learning new things at breakneck speed. So, Martha is so good at this. You guys know this is an exciting time. This is like AI. It's exploding, and we're getting all these new tools. I would hate to be a pharmaceutical executive is seeing what we're doing, because it's looking as if so many diseases are either initiated or dominated by microbiome issues. Hyperuricemia, high uric acid, that's a disease of the microbiome. High oxalate levels, that leads to oxalate kidneys. That's a microbiome issue. Dementia is at least in part largely a microbiome issue. Coronary disease, who would have thought, thing I managed for many, many years, a microbiome. Atrial fibrillation, a microbiome issue. Go down the list of all common conditions, and you'll see this. If there's not a major, not an initiating role, at least a major participating role of the microbiome.
I love it, Bill. I think I may know another sort of piece of the puzzle of rhodori. Our formula Sugar Ship was designed to convert sugars, glucose and fructose, into mannitol, but it does that, but it also maintains homeostasis. So if you are low on glucose and you need glucose, it can actually reverse the cycle and produce glucose for your blood. Well, so there are 3 microbes in our formula that are producers of mannitol, and rhodori is one of those producers. So I think one of your mechanisms is potentially works in a mechanistic way of helping to balance glucose in one direction or another. If there's too much, it turns it into mannitol, and if there's not enough, it converts it back to glucose. And then what you're talking about, the other ingredients, I think I talked to you about this the other day, the glycocalyx. So the fuzzy layer that coats everything, our cardiovascular system, but all our cells, the lining of our gut, everything is, and the glycocalyx is a sulfated polymer that's made of hyaluronic acid and like chondroitin sulfate and the collagen type molecules. And so because you've got those pieces of the puzzle in there, and then you've got a polyphenol, I think what you're doing is also supporting that glycocalyx. So I would expect you to also see cardiovascular improvements and kind of across the board because you're supporting that glycocalyx.
You know, I find hyaluronic acid endlessly fascinating. I tell ladies about it. They say, "Oh, don't tell me about hyaluronic acid. I buy it already. I pay $120 or so for a 1 ounce vial of hyaluronic acid. I put it around my eyes, and it works. It reduces wrinkle depth." So I asked them, "What did it do for your neck skin, or your chest skin, or your thigh skin, or abdomen?" Of course, nothing. So local topical application is local and topical. So because of this silly cut your saturated fat and cholesterol advice over the last 40, 50 years, everybody abandoned sources of hyaluronic acid. And hyaluronic acid is so critical for not just for skin appearance, because hyaluronic acid provokes formation of collagen in the dermal layer of skin. It also causes moisture retention in the dermal layer, causing plumpness. I know ladies are big on plumpness of skin. That's what young kids have. It also stimulates chondrocyte production of collagen in your joints. It also increases synovial fluid volume. That's the lubricating fluid in your knees and hips. And as you point out, Martha, and it's the major constituent of the glycocalyx. So now we need more work on that. But my prediction is that hyaluronic acid is one of the most underappreciated ways to reduce cardiovascular risk. Because the purpose of the glycocalyx, if you guys don't know, they're finger-like projections lining the arteries, the so-called endothelium. And they're signal molecules, and they control the tone of arteries, whether they're constricted and leading to disease or relaxed and not leading to disease. So the glycocalyx is easy to disrupt. Many things disrupt it, including not getting hyaluronic acid in your diet. And even more incredible, it's a fiber. You know, most fibers come from plants, right? Legumes, vegetables. Well, hyaluronic acid is a fiber that comes from animals, from brain and skin and tongue. And when you consume hyaluronic acid orally, not topically on the skin, but orally, it blooms the butyrate producing species. I'm sure you guys have talked about this. Species like Calibacterium, Akkermansia, Lacnospiraceae, Ruminicaceae, the species that produce butyrate or butyric acid that in turn mediates many of the benefits: deeper sleep, weight loss, reduction of insulin resistance, reduction of blood sugar, reduction of blood pressure, and better skin. I know ladies love that, right? Because the butyric acid acidifies the skin. So you may not know that healthy skin is very acidic, has a pH of about 4.5. Unhealthy skin, say someone with acne, eczema, seborrhea, psoriasis, all skin diseases, their skin is less acidic, about 5.5. Remember, the pH scale is logarithmic. So healthy skin is tenfold more acidic than diseased skin. And remarkably, people with those skin conditions, it's not just the lesion that's less acidic, it's the entire body, the entire skin surface is less acidic. So you get hyaluronic acid and some other fibers too, and you bloom those species that produce butyric acid, it acidifies the skin. When that happens, you see a shift in microbial composition in the skin. You see Staphylococcus aureus, that nasty microbe, go down, and you see Staphylococcus epidermis become dominant. And that helps suppress skin rashes, blemishes, redness, etc. So the hyaluronic acid is hugely effective, and it reduces proteobacteria. Those are the bacteria, fecal microbes, that have invaded, have overproliferated in your colon and invaded your small intestine. And that's how you get depression, anxiety, dementia, psoriasis, rosacea from your microbes in your GI tract. So hyaluronic acid contributes to a reduction in proteobacteria, thereby endotoxemia, and it increases the thickness and integrity of your mucous barrier, protecting you from those microbes. So hyaluronic acid, this thing abandoned by modern people because of misguided diet. So, you know, dietary guidelines have made blunder after blunder after blunder. Remember, we're told to replace saturated fat with margarines. Remember that? Hydrogenated fats, high temperature, hydrogen gas bubbled through oils to solidify them. So you bought margarine. And many of us bought Parquet, Mazzola. Remember all those? Well, it's estimated that 50,000 excess deaths occurred per year until Congress passed legislation to ban the inclusion of hydrogenated fats in your food. Time after time, dietary guidelines got it wrong. And here's another example of how colossally wrong they got it, because they told you to stop eating saturated fat and cholesterol, so everybody stopped. Your great grandma would eat thymus and kidney and liver and stomach and intestine casings for her sausage, right? We all abandoned that. Most people tell us, the most modern people, they say, yuck, I can't do that. So we lead this diet as a result of misguided dietary guidelines that impaired your health, skin appearance, joint health, body composition, and probably cardiovascular health as well.
So interesting. So what is your reuteri? I mean, you have a specific like number, because we talk about strain specificity, and I know yours produces a reuterin, I believe.
Yeah, the parent strain is an ATCC strain.
Okay.
Yeah. All we've managed to do is compare it to 4 other strains, and there seems to be no difference. You know this, Martha.
Yeah.
We don't have pharma budgets.
Right.
Our budgets are a rounding error in the pharmaceutical industry.
They most definitely are. Well, ours, the one that we use, PCR7, it does not produce reuterin, but it produces a bacteriocin called lanticin B, which is a lantibiotic, and it's effective against gram-positive bad guys like streptococcus, staphylococcus, enterococcus. So, and what's interesting hearing you talk about like what's happening to the skin. I have a doctor out in California who, was using the sugar shift for somebody with, trying to help them with some metabolic issues. And they had eczema for like 20 years, and the eczema reversed, taking the sugar shift. And, I was trying to think about that. And so when I had Raul going back, looking through the genome to find the bacteriocins, then that you saying that about staph, it makes sense to me now, how like all
That's
those
very cool
little pieces come together.
I always thought our species to attack gram-positives was kind of a hole. For that reason, I changed my SIBO yogurt composition. We took out the Bacillus coagulans and replaced it with Bacillus subtilis for its gram-positive, gram-negative bacteriocin effects. I'm too early to know if that's better, but I think it's going to be better.
So, our sugar shift has Bacillus subtilis in it. And I mean, these microbes are never endingly fascinating to me, because they just do so many interesting things. But I had a call yesterday with a woman who founded a company called Good Fight, PHYTE, and it's a phytase enzyme. And if you're a vegetarian or you eat a lot of vegetables, the minerals are bound up in phytate in the plant. And if you don't have the phytase enzyme, you can't access the minerals in the plants. And so I wonder sometimes if that isn't part of the problem, with the vegetarian diet, at least in part, you're not getting access to the minerals. And then glyphosate binds the minerals up even tighter. But this phytase enzyme, of course, anytime somebody has something like that, I'm like, okay, well, which microbe makes it? And Bacillus subtilis makes phytase. So I was like, okay. So
interesting, Martha.
Yeah. So another reason to love sugar shift or your yogurt. And I think Kieran, and he was with Microbiome, or he sold his company to Microbiome Labs for a long time, and they have a single species of Bacillus subtilis called HU58. And I know, a number of people who've had some pretty serious gut issues who've used that to kind of reset and help the gut. So, I'm not always just promoting my products, because I think there are some good products out there. We just happen to take a different approach to how we put together the teams to work together and support each other. But I think like your yogurt and thinking about how you're picking those different strains is sort of that same kind of thinking, is like, let's get the right guys together who support each other and support what's going on in your gut. And, like we have so many people who do your protocol and do the Rotary yogurt. I mean, I'm just having a big bowl of the yogurt right now, but, so
have we talked about Bacillus subtilis sparkling juice?
No. Why don't you tell us
Let
about
me tell you, the people in my group already know this, so sorry, but it's proven to be a lot of fun. So it's an alternative. You can make the subtilis as part of your yogurts, of course. That's the third ingredient in our SIBO yogurt. Or you can make rotary gaceri for the SIBO yogurt and make the sparkling juice separately. And I love inexpensive workarounds. If you go to Aldi's or to Costco, they have kombuchas. It's not kombucha. It's mislabeled, but they call it kombucha. That's made with Bacillus subtilis DE111 strain.
That's ours.
Okay, if you buy it from Aldi's, it's $2.19. Take a quarter cup, pour it into any volume of juice. Just make sure there's no preservatives, no potassium sorbate, no sodium benzoate. So pour that quarter cup into your juice. Cap, agitate lightly, loosen cap, very important. And then for subtilis, you want to, I've been getting best results at 90 degrees Fahrenheit for about 60 hours because we want the juice to ferment. We want all the sugar gone. Yeah. It's going to produce huge amounts of carbon dioxide. That's why you leave the cap loose. If you have it too tight, it can explode and make a mess in your kitchen. So leave it loose. You may have to vent it now and then, or you can always go to a beer brewing store and buy a venting cap if you don't want to watch the thing. But 90 degrees, 60 hours, taste it. If it's still sweet, let it go another 12, 24 hours. We don't want sugar. And it's delicious. I'll ferment, for instance, mango passion fruit juice. And it's no longer sweet, but it's effervescent. Pour it on ice or drink it straight. Half cup. There's a little bit of sugar left. And it's a really easy way to get Bacillus subtilis and get all those potential advantages, gram-positive and gram-negative.
So that's really interesting, that the carbon dioxide. So I'm going to go back to the glycocalyx for a minute, because the work I'm working on this Parkinson's paper with Dr. Ninham in Australia, and one of his areas of expertise is the glycocalyx and something called nanobubbles. And nanobubbles are basically what move through the glycocalyx. So oxygen and nitrogen nanobubbles move up through the glycocalyx and are delivered into the blood, and the carbon dioxide comes out. But carbon dioxide is also a signaling molecule for the release of hemoglobin. And so I've been like thinking about how fermentation and the fizzy bubbles in there are somehow helping, with all of that. And so I'm going to jump back over to, or not back over, but I'm going to jump to this glucose 101, because the red blood cells, the only energy, source that they use is glucose. And it's glucose that's either coming from glucose that you're eating, or glucose that you are making via gluconeogenesis and delivering back into the blood, which is a pretty complicated process with a lot of places for it to break. And carbon dioxide is signaling those red blood cells related to hemoglobin in the tissues. So I don't know where I'm going with that, but the carbon dioxide bubbles and like what's in these fermented beverages, because it's not just carbon dioxide bubbles. It's also probably a lot of really valuable secondary metabolites that we don't have the money to test. And, you know, kefir is like that. It has a tremendous amount of, you know, nutrient density, but it's also very fizzy. You know, a good kefir has a little fizz in it. And I think that's partly how some of this, these nutrients are moving around in the bubbles. So anyway, that's my current crazy idea. but I love the idea of this. So I use the kefir or the kefir juice starter from Cultured Food Life, or is that what it? Yeah, and I use tart cherry juice, and I have a glass bottle that has one of those little flip top things, but you know, it seals it really tight. And the other day I got it out to try it, and it sprayed all over my kitchen because the pressure had built up so much.
Have you guys talked about the effects of infrared light on the microbiome?
We have not. I would love for you to talk about that a little bit. I have some infrared light here, but was looking at it related to the mitochondria and not the microbiome. So I'd love to hear what you have to say about that.
I'm not an expert, just dabbling in it, but I was surprised to see several animal and human studies where red light. So we have evidence like Glenn Jeffrey's study out of UK. We did something crazy. He took red, in this case, 670 nanometers wavelength, visible red, and shone it on the backs of people, or no light. So red light or no light on people's backs, their upper backs, and then did a glucose tolerance test. And the people who got red light had a better glucose tolerance, less area under the curve, lower peak glucose. Then he also measured carbon dioxide as an index of carbohydrate metabolism. And the people who got red light to their back produced more carbon dioxide, signifying better carbohydrate metabolism. So that was one of about a dozen studies suggesting that location doesn't always matter with exposure to red and infrared light. Well, there's now several studies where animals, for instance, red light was shown in their abdomens, and there was a shift in microbiome composition towards butyrate-producing species, and even more remarkably, these are animals, you can kill them, sadly, and they were given a compound to cause dementia that looks just like Alzheimer's dementia. And animals who got 730 nanometers of red did not develop any beta amyloid plaque or phosphorylated tau. Those are the markers for Alzheimer's. The mice who got lower wavelength or higher wavelength did develop all the hallmarks of dementia. So there seems to be, if we believe that one mouse study, an improvement in cognition and brain anatomy, brain pathology with exposure of the abdomen, not the brain. I point that out because I see, you know, I hate people being sold crap that you don't need. And I see people buying $18,000 full body beds and $4,000 helmets. Here's my $82, it's hard, that's kind of on the cord. Here's my $82 device. It's about 16 inches long. And you can shine it on your head if you want, or your abdomen. I paid $82 because you don't need those fancy devices. They don't tell you that, of course, because if you're willing to spend $2,000, $3,000, $4,000 for a helmet for your brain, they're more than willing to sell it to you. But anyway, so mouse studies, complete ablation, not partial, complete ablation of beta amyloid plaque and phosphorylated tau. Now, we can't section human brains, so we don't have direct evidence like that, but this has been done in people with cognitive decline, and it does halt the progression of dementia. Now, it's not quite clear. Does it need to be shined on the head? Is the abdomen okay? Is the back okay? So this is an open question. So nobody really hasn't done that study yet. But there seems to be now. But don't get too excited, because remember, red light can be no better than sunlight. Right. So if sunlight cured everything, there'd be no dementia. no diseases at the
Well, if
equator.
people actually went out in the sunlight. Yeah.
Right. So I live in suburban Chicago. I know most of you live in northern or cold climates. You know, today was the first sunny day that you get sun in about 4 months. So we can't, but if you're in Florida or California or Arizona or Texas, you probably don't need to even think about this. Just go outside. Now, there may be something unique, though, about abdominal exposure and its effects via the microbiome. So emerging science, but kind of interesting.
So that takes me back on a couple of things. So John actually had a light helmet. There's a company in Australia that is studying red light and Parkinson's, and they sent John a helmet to try. And they also made a device for the belly to wear around the belly. He did not get one of those, but they recently released that. But what was interesting also, oh gosh, back in the beginning, so maybe 2017, 2018, when we were sequencing people's microbiomes, when we were collecting samples and looking at Parkinson's versus controls, we found a difference in something called phytoene dehydrogenase. And that is involved in, it's like a light enzyme. And, I called Jack Gilbert, who was my co-founder at the time, and I was like, we have this light, there's photosynthesis in the gut. And he's like, no, there's not. There's no light that gets in the gut. And I'm like, there are light waves that penetrate the skin. And so I think very much that's going to be an emerging area of exploration in how light affects that. And then I have another friend whose son had kidney cancer when he was like 4 or 5 years old. And one of the people he talked to told him, get sunlight on his back. So, if you think about that red light and the glucose metabolism, and, maybe it's doing something to improve, kidney filtration, or something that's going on in the kidneys and the kidneys and the microbiome together. But, I definitely think that there are light effects to the microbes for sure, because also when we're over working on the ag stuff with Raul, and then I have another doctor that I'm working on a strain of bacteria called Dietzia that he has studied in animals and humans. It's effective against Mycobacterium avium paratuberculosis, which is known to cause Johne's disease in cows and Crohn's disease in humans. And so we're trying to grow this bug at scale. And it's been kind of challenging, but I think once we get it done, it'll be hard for anybody else to get into the market because it's not an easy bug to grow. But it makes a pigment. So it makes an orange pigment. And there's something to what's going on with the pigments and different light. And, we tried doing it in the dark in different light spectrums at different, and, we grew at one place and it worked, and another place and it didn't work. And I think there are a lot of factors, and, people in the fermentation industry know this well, that microbes don't always behave the same way. And we see that in yogurt. I get more questions from my customers about the sugar shift yogurt than any other thing we do, because, they'll go along and they'll have, 15 beautiful batches, and then they get one that's like cottage cheese. I'm like, there are so many things that can change how they behave, from barometric pressure to, humidity in the air and all of that. And, the companies that work on this stuff at large scale, they know it quite well. And, once they get a process perfected, they are very vigilant in how they focus on that. So anyway, that's a long way of, but light, I think, is going to turn out to be really underappreciated, and electromagnetic fields.
Mm-hmm.
So one of the things I reread a book. I don't know if, are you familiar with the work of Robert O. Becker, The Body Electric? He was a orthopedic surgeon and did a lot of research on bone regeneration, and a lot of work with like salamanders and stuff that can regenerate their limb. They can regenerate full limbs. He did all these different things. And one of the things in his research was like the salamanders and frogs and stuff that they were looking at. They make red blood cells that de-differentiate and like turn into a stem cell and can become anything. But humans don't do that. But we actually do. So we make steady state in our bone marrow red blood cells. When we're under stress, we make stress erythrocytes, and they are made in the liver and spleen, and they are more like a fetal hemoglobin, and they're de-differentiated. And I think there's some piece of that puzzle that has to do with what's going on in people's blood sugar and the stress that we're under. And, you know, if we have maybe too many de-differentiated red blood cells that don't know that they're red blood cells. And so we've got this sort of haywire, what's going on in our blood. So I'm going to back up to light for a minute, because we had a call last week with Dr. Hans Vink, and he's the Revasca guy that does the glycocalyx, but a lot of his early research was in live imaging blood moving through capillaries. So like imaging, so he has images of the endothelial surface, those little hairs. I mean, the images are incredible, but he has live video of like a red blood cell moving through a capillary. And he made a comment. I have to go back and study the transcript, because like my mind was like, whoa, because he was talking about when they were photographing the red blood cells, and when they turned the light off, how the blood cells changed, the shape changed, the movement of them, everything changed when they turned the light off. So there's something going on in the red blood cell with light also. So anyway, we're digressing way off the microbiome here for a moment, but I think it's, you know, everything's connected.
Just on the red light thing, I've never heard anybody talk about this. So it's the enzymes that are light reactive are sometimes called chromophores, and the chromophores in your mitochondria that seem to be the light mediator is cytochrome C oxidase. And these are of course enzymes. They're microscopic and beyond the detection by sight. But here's something I noticed. So I'll turn my red light on. You don't want to look directly into it because it hurt your retina. It's good for your retina, but not this intensity. The devices made for your eyes are much, much lower in their output. So don't use this for your eyes. You have to buy special devices for that have been tested for safety. But if you have just a cheapo red light like I have, don't look at it. Look down, because that's where you want, like you're in the sun, and it hits the bottom of your retina, the so-called retinal ganglion cells. But tell me this: if you do that, do you see bright white dots of light? And if it's your first time you've been sun deprived like me, they'll last for 20, 30 seconds and then disappear. And the more you do it, the less they appear. And it made me wonder if we can actually see somehow the chromophores absorbing light, because they're pinpoint. tons of them. And watch, if you can, focus on one. You'll see it lasts 20 seconds first time you do it. Next time you do it, lasts 10 seconds. And they get short. I'm convinced we can see our own chromophores. I'm not sure how.
That's really interesting.
If it's true.
So, there's a glycocalyx in the eye too. So, and this is one of the things in working with Dr. Ninham and working with John that we noticed when certain things that we're pretty sure were collapsing the glycocalyx would also change his visual perception. And so if you, like, there's two different kinds of Parkinson's primarily. One is tremor dominant and the other is what's called posture and gait, and they're tipped over. And I asked him, I said, does it feel like I know that what you see is not what I see. And does it feel like the earth or the ground is falling away from you? And he said, yes. And so when I was describing this to Dr. Ninham, who understands the physiology of all this, he said, that's also the glycocalyx in the eye collapsing and changing visual perception. And while I'm working on a documentary with people with Parkinson's, and I had a conversation with a group of wives of people with Parkinson's, and they probably half of, it was a dozen people, and half of them, their husbands wore something called a prism glasses. So in a prism glass, like, you're seeing double basically. So there's something in the perceptive field. And like one of them, probably 5 years before he was diagnosed with Parkinson's, he was a golfer, and he'd be out golfing, and all of a sudden he could not see the ball beyond 50 yards. So he's tracking the ball perfectly, and it just vanished. And so then I started talking to lots of other people with Parkinson's. Do you wear prism glasses? And I'm surprised at the number of people who wear prism glasses. So I think this glycocalyx is going to turn out to be a huge, and like most people think it's the vasculature. Well, it's the vasculature, it's the eyeball, it's the blood-brain barrier, it's the red blood cell membrane. It's the bomb.
One more thought about hyaluronic acid, because I'm endlessly fascinated by this thing absent from the modern diet. In general, not always, but in general, when you talk about components of food, you have to consider larger quantities. This was an issue with omega-3 fatty acids from fish oil. In the early days, people were playing with like teensy-weensy doses, but it's a component of food. You have to talk about larger, like gram quantities, and the evidence is now clear after 30 years of debate that it takes doses upwards of 3 grams or more to have true biological effects. And by the way, there's ample evidence now that omega-3 fatty acids in sufficient doses north of 3,000 milligrams per day facilitate regression of coronary atherosclerotic plaque. So whenever you have a component of food, you got to talk about larger quantities. Hyaluronic acid is a fiber from meat, from organs. Yet we talk about 120 milligrams. That's the standard dose. All the skin trials that increase dermocollagen, reduce wrinkles, is 120 milligrams. And all the studies looking at decrease in arthritic pain in diseased joints, all use 120 milligrams. Only one time have I seen a study use 240, and there was no incremental benefit. I believe it was a skin trial, so they abandoned it. So we have all this evidence that 120 milligrams of hyaluronic acid is effective, but it's a fiber. If I said, hey, you should have some bran fiber, how much are we talking about? We're talking about 30 grams, 30,000 milligrams. Yet we're talking about 120 milligrams of hyaluronic acid, 0.1 grams. So if 120 milligrams does a nice effect, how about 1,000? How about 1,200? How about 5,000? No one's ever tested it. So I don't know, but it's an interesting question. It's really hard to figure out. I could not find analyses of brain tissue, animal brain tissue. So if you had some lamb's brain today, how many milligrams or grams of hyaluronic acid would you obtain? In other words, is there a precedent, some defining quantity that we used to get that we're now not getting? I could not find it. There's almost no analyses that I could find of hyaluronic acid content of brain tissue. But something to think about. Should we increase it? Because if you do, could you enjoy even better skin appearance? Could you enjoy even better joint health? Could you enjoy even better arterial and brain health? Because the brain is largely hyaluronic acid too, as well as DHA, by the way. So anyway, an unsettled question that bothers me a lot.
Have you tried or thought about trying putting the hyaluronic acid in with the yogurt?
You mean for fermentation?
Yeah.
I thought about it, haven't tried it yet.
I'm thinking I might try that next time and see what happens. And then, like, so if you ate, like, I make short ribs, you know, they have a lot of collagen type, you know, I don't know what but I'm wondering, like, what a dinner of short ribs has in terms of hyaluronic acid, or, you know, what kind of high hyaluronic foods, you know, what would a normal amount you would be consuming in a dinner meal?
You know, because it's been so sorely neglected, Martha, to my knowledge, no one's done those analyses. We'd have to do them ourselves.
Yeah. Yes. If we only had a pile of money, Bill, we could do so much. Yeah, it's
you know, I think we've all accomplished a lot despite that, despite not having billions and billions of dollars. So we're going to launch that body composition trial. I hope sometime soon. We got that little skin trial. We did a little mouse trial. We're launching another mouse study. We're having a hard time with the ELISA measurements. So we're going to repeat some of the mouse measurements. We'll get it done. It takes longer. People get impatient. They're used to watching TV and seeing a new drug come out every day by commercial. We don't have that kind of money to do that.
You know, you were talking about the animal model for dementia, and I don't know, like, which one you use, but I looked early on at, you know, what are the different animal models? So, you know, endotoxin is used in a number of diseases in the animal models. So diabetes, Parkinson's, like autoimmune, some of the autoimmune things, but Alzheimer's, there is a streptozotocin model of Alzheimer's, and it's used in a couple of other, and streptozotocin is made by microbes. So it's like, okay, like, then why aren't you looking at the microbes that are making endotoxin or making streptozotocin? Or it's like, why don't you look at these things that you're using in the models to create the disease or something that mimics the disease? You know, they're all made by microbes.
That's very cool, Martha.
It's, you know, it's just kind of boggles my mind when I look at that stuff, and I'm like, do you guys not ever, like, just sit around the room and ask questions? I mean,
do you know if it's any species or strain?
You know, I'd have to go back and look. I actually wrote an article that I was trying to get my PR person to get in the New York Times probably 7 years ago, and I'll have to dig that up because I wrote about that. I was like, you know, this is just insanity. Which brings me to the starvation study, the Minnesota starvation study. So that was a study to look at the effects of extreme calorie restriction. And so they took these conscientious objectors and they starved them on a low calorie diet, and they tracked, you know, all these different markers of what happened to them. And then they refed them and did a bunch of tracking in the refeeding process. And then some of them, they went back later and talked about the, you know, longer term effects. And it, you know, it changed people's relationship with food, where they had like obsessions with food. It changed their, like, metabolic switch capability. And like there's a whole bunch of stuff. But if you look at it, because part of the focus was on micronutrients, which is minerals. And we are starved of minerals because of glyphosate, because it binds up all the minerals. So the plants are not nutrient dense. The animals aren't nutrient dense. We can't get the minerals. So, and minerals are needed for all of those enzymes to work properly. So if you don't have the minerals, you're in serious problems. So if you wanted to engineer metabolic disease so that you could sell people all these drugs and then create a biohacking industry to put trackers on people and do all this stuff, that's exactly what you would do, is starve them of minerals. And you would kind of follow the protocol of the Minnesota starvation study. And Ansel Keys, there's the bad guy with his fingerprints all over it again.
And, the modern diet is also very phytate rich, as you pointed out earlier. And I focus on that from the grain standpoint, because the phytate content of wheat in particular has been increased because farmers love phytates, because phytates are pest resistant, molds and insects. So they hybridize and bred wheat to increase phytate content dramatically. But as you point out, Martha, the phytates also bind all positively charged minerals, calcium, magnesium, zinc, iron, and you poop them out. And so, so that in combination with glyphosate and nutrient poor produce, and mineral deficiencies are rampant.
Right. And the microbes need the minerals. They're the guys that move it all around. So I talk a lot about my favorite little book, The Life Bridge, which I'm trying to write an update since the guys who wrote it won't write an update. But it's that, the microbes take the minerals and turn them into living matter. And like, if they don't have anything to do that with, well, guess what? They might get it from you. They might just eat you.
Have you guys talked much about fungal overgrowth?
We haven't. I do get questions from people on the customer side that fungal growth is, likely a big contributor. We did talk about fungal toxins, the mycotoxins, but we didn't talk about fungal overgrowth. So that would be great if you want to kind of talk a little bit about that. CFO or.
Yeah, I think it's underestimated just how common this is, especially in a carbohydrate, sugar-rich diet, because fungi love sugar. That's why, type 2 diabetics who are poorly controlled, which is very common, they'll have fungal rashes behind the ears, scalp, under the breasts, forehead, under the in the groin, and their toenails and their fingers. They're walking fungal farms. And of course, you got to wonder, does that apply to other parts of the body, like the brain? Ruth Alonso from Spain has done elegant work with brain sections showing that people with dementia have brains filled with fungi compared to people without dementia who have no fungi in their brains. Now, that doesn't tell you cause and effect, but it suggests fungal species probably play a role, as do oral microbes, of course, like Porphyromonas and Fusobacterium. So what do we do about that? One thing I think I'm seeing, and this is very poorly charted in the science, if you have fungal overgrowth, you do a stool analysis, and there's an overgrowth of some species of fungus, Candida glabrata, Candida albicans, Malassezia, whatever. Of course, you can't tell whether it's colonic or whether it involves a small bowel, because stool testing is rectal testing. Martha will tell you, right? When they did full bowel movement testing, it looks nothing like rectal testing, but most of us have only access to rectal testing. But you can't regionalize. You can't tell where those microbes came from. So you really can't diagnose CFO with stool analysis. You can only say there's fungal overgrowth. We don't know how extensive. Can't say that. But here's some I think we're seeing. People who have fungal overgrowth in their GI tract seed other parts of the body, whether it's toenails or under the breast, skin, maybe brain, airway, sinuses. And one of the things I'm seeing is at least half of eczema is fungal local growth. In other words, if you had a fungal, eczematous rash, and you tried steroids, all that kind of stuff, try a topical antifungal. It could be Lotrimin from Walgreens or Walmart or whatever, or it could be an essential oil like clove oil, cinnamon oil, or oil of oregano. Diluted. They're very
I was
caustic.
going to say diluted or
Yeah,
you'll be burning.
Yeah, they're very caustic, so you have to dilute them, like several drops in a tablespoon of coconut oil, avocado oil, whatever, and use it as a salve. And that's antifungal. And because if it goes away, which if it is fungal, it'll go away within 24 to 48 hours. It's even if you had an eczema rash for 20 years, it'll be gone. If it's caused by local fungal infestation of your skin. But what I think I'm seeing is fungal infestation to other seeds of the body. It makes me wonder, if a tree or a plant dies in the forest, the first things that colonize are fungi. They're the things that reclaim organic matter and turn it back into nutrients and soil. So is the expansion of fungal populations in our bodies as we age, this is nature's way of reclaiming us? And can we have an effect on eradicating them to put a stop to that aspect of aging and health deterioration? Don't know, just a speculation.
Well, that's interesting. It's probably been 5 or 6 years. There was a scientist there was a news article, but I think it was about her actual research about fungi in the body. And then, when we die, basically the fungi reclaiming the body and talking about that. But, so malassezia and seborrheic psoriasis are both associated or comorbidities often with Parkinson's, which I think is interesting. And like the oral microbe Porphyromonas is there's a number of studies with Porphyromonas and Alzheimer's in the brain. It makes a black pigment. So like when you spit in the sink, you have gray or black spots on your sink, that's a good indicator that you may have Porphyromonas and you need to get to work doing something. It's a very difficult microbe to get rid of. And so my husband had it in his mouth, and we also found it, a relative of Porphyromonas gingivalis is from the mouth, called Porphyromonas bananas, elevated in our Parkinson's sample set. And, so it's probably, it's gone into the gut and changed a bit, but it's still a bad guy. But it is an organism that doesn't have any iron siderophores itself to acquire iron, but it works in consort with Streptococcus. And so Streptococcus acquires the iron and feeds it to the Porphyromonas. And it is very antibiotic resistant and difficult to eradicate.
Cool stuff, Martha.
So do you have a few minutes for questions? If we have people who have questions, you can either post your question in the chat, or if you want to raise your hand, there's a little hand at the bottom. You can raise your hand, and we'll see if we have any questions. We have Jan has a question.
I have a question, but as an aside, first, I just wanted to say that I was listening to Peter Attia's latest podcast today, and I'm at the very beginning, but his guest is a diabetes researcher who was a participant in that Minnesota starvation study. And he wasn't one of the 90-day volunteers. He was, I think he said, the 5 or the 7-day. And the reason he did it was so that because they were giving them $50 and he was a college kid. So anyway, that was funny. Okay, well, I posted a very bad question in the chat. I just am trying to gain clarity with this relationship between all these topics that we're talking about, and now they seem to be related. That red light activates CO2 is step one. Is that correct? And then CO2 has to do with carbohydrate metabolism.
Yeah. So
Okay.
you exhale carbon dioxide as
Carbon
a reflection.
dioxide.
Yeah, as a reflection of glucose metabolism. So it's just a gauge of glucose metabolism, Jen.
And
To my knowledge, no one's worked out that. That's a big controversial issue in that whole red light area. How did Glenn Jeffries shining a light on the back result in presumptive cellular uptake of glucose? Why? What cells, where, and why?
In the red blood cells. In the red blood cells.
Blood cells, pancreas, pancreatic insulin, muscle cells.
I'll bet you it's the red blood cells based on what Hans Vink observed that he reported in our talk last week. And so in the glucose 101 protocol, Dr. Stevens talks about getting insulin resistance of the brain from trauma. So head trauma, he was doing work with high school students, with athletes with concussions, but he later found any kind of trauma or stress, the blood-brain barrier seals off, and then when it opens back up, it's a little less permeable to glucose uptake. And so each time you have a stressor like this, you're less able to take up the glucose preferentially into the brain. Well, so he doesn't talk about this. I mean, maybe he knows it, but maybe he doesn't know it. So the brain, the GLUT1 transporter is what carries glucose across into the brain preferentially. The GLUT1 transporter is also what carries glucose into the red blood cell, and red blood cells ferment glucose, they do glycolysis for their energy. So if you're getting GLUT1 resistance from stress, back to our stress erythrocytes, you probably have a bunch of red blood cells that can't uptake glucose because they don't know what they're supposed to be. So it's kind of the same thing. And he has this protocol where it's about 6 months long, where you're loading an amount of dextrose to reset the system. And I think it's because it takes about 6 months for you to get a full set of steady state erythrocytes that aren't stress erythrocytes. But it's like so counterintuitive to the keto people and like all of this stuff, but it really fit in. Like it clicked for me when I read the starvation study. I was like, oh my God, like we have been starved to death. So I don't know, like what you think about that, Bill, but
it's a great thought. It's a great thought. But to my knowledge, at least the red light reduction in glucose thing, there's no solid science beyond that. Speculation type. It's going to be settled sometime, but there's no answer right now.
I'll do a little more digging, see what I can find. Mahaleen has a question. And then I have some in the chat I'll ask.
You're muted, Maha.
You're muted, Maha. Okay, let me read some of these questions while you try to find your. Okay, so from Kimberly Littlejohn White, can you repeat the recommended frequency for red light? There was a frequency range that sounded like it was detrimental. Can you please restate that?
So red infrared is not detrimental. Blue is. This has nothing to do with the microbiome, but I'll tell you real quick. So I'll tell you my personal experience. So I changed all my house's lights to blue LEDs, like most people have. Energy savings, right? 75 and 90% less energy required. But most LEDs are blue emitting along with visible light with no red or infrared. So I noticed, this is some time back, I can barely see the computer screen at night. I can barely see the darn thing. I'm having trouble seeing in the daylight. So I thought, wait a minute here. So I replaced, I have a desk lamp right here. I replaced both LEDs, blue, with old-fashioned incandescent that has visible and red, infrared. And lo and behold, within 48 hours, all my visual problems went away. So it's not just getting red, it's also being careful of your exposure to blue. That's why I can see Martha's wearing blue blockers. I've got blue blockers because we're looking at an LED screen emitting blue. And blue gives you cataracts. That's quite solid. Blue is suspected to cause macular degeneration and deterioration in visual acuity. So blue, especially after about 4 p.m., has real serious effects. It also suppresses your production of melatonin. That's why you hear this advice to not get exposed to blue later in the day because you can't sleep, right? But it's even more than that. It's detrimental to visual health, to eye health. Getting red that science is very good in preventing myopia in kids, nearsightedness, but they have to get exposed every day. And once they stop, vision returns back to usual, not normal, but usual. So it has to be probably done until they stop growing, and because the eye elongates, causing myopia or nearsighted vision. Now you can't use a standard red light though to do that with a child. You have to get a device specifically tailored for the much lower intensity that you can look directly into. So that's completely different. But the bottom line here is, red light has beneficial effects on eye health. There's some uneven information suggests red light, not directly, may reduce macular degeneration. So there's that also.
Is that 650 nanometers? Do you know?
For that, one of the problems we're having is because it's a range. So visible red's around 670, infrared starts at 750 and higher up to 1,000 and plus. No one's actually charted out except that mouse that I told you where it was 730 specifically. That was the only wavelength that reduced phosphorylated tau and beta amyloid plaque. Most other studies will do 1, 2, or 3 different frequencies, and we don't know which one did it. But until we know better, 670 visible red is a very safe one, and 730 to 830 infrared. You can't see it, but that you can't see. You'll feel it though. So if sunlight shines on you, you feel warmth, right? That's infrared. If you put, like my device, my cheapy device here is 670, and I believe 830. And when you turn the 830 on, the infrared, you can feel it. You can't see it, but you can feel it because it's heat. So I think the best thing to do, one, don't spend a lot of money. Don't spend a lot of money. Buy an inexpensive device, probably 670 and some other wavelength, 730, maybe 830. Some of these devices will provide 2 or 3, sometimes more choice. So try to find with choices. This is going to evolve over time. We may say, oh, that was wrong. And here's a better way to do it. So one thing I would not do is buy one of those expensive devices. Don't do that.
So just a couple of light observations I'll tell you about with John. So I still work with a scientist at the University of Denver's Center for Aging, and he's in the bioengineering department, but he's a biochemist, and I've taught him about the microbiome. He's taught me about biochemistry, and he made a light cap for John that had different colors. So you could select different colors. And so one day we had to get it repaired. And so we went over to his house to get it repaired. And John was pretty tired that day. So he was like, and if you know anything about Parkinson's, a lot of times when they're tired, they lose facial expression. And so, he was sitting in the chair and really had no facial expression at all. And Dr. Paredes fixed the cap and set it on John's head. And this other Dr. Hernandez, who was another friend of Daniel's, who's like electrical engineer, an MD, and some other kind of PhD, like super genius, in his 80s, like has done all these incredible things. And he's sitting there, and John sat down in the chair, and they put the cap on him and turned the white light on. and it was like they had turned John on. Like his whole facial expression, everything changed. It was like he came back to life. It was insane. And Dr. Hernandez was like, I've never seen anything like that. It was great, but it was the white light. Which is, white light is all spectrum. So, so that was interesting. But then in terms of blue light or these really strong fluorescent lights, we had noticed in the last several years, like he could not go to a Costco because he'd be walking fine and doing fine. And we'd get to the Costco and the big doors would open. And, they have just really, really irritating lights in there. And he walked across the threshold and could not move. It was like he was turned off. So light is, it's a big deal, people. It's a really big deal. And here we sit staring at a blue screen, but I do have my blue blockers on. Okay. So we have, let's see, on the Sugar Shift Challenge, a couple of us gained weight when we used a half a cup of yogurt today, even when limiting carbs to 5 carbs per meal. What do we think of this?
That's great because it's muscle. So that's what we're seeing. Personally, I gained 13 pounds of muscle in the first 3 weeks I did this. And I know about you guys. I hate going. I despise going to the gym. I'll go, but I hate it. I actually haven't been to the gym in a year. But when I first started the yogurt, I was going to the gym once, maybe twice a week for 15 minutes and get the hell out, right? And I gained 13 pounds of muscle and my strength increased by 50%. In my early 60s, this is 5, 6, 7 years ago, right? So I'm doing lat pull downs, 130 pounds for 10 repetitions. I take the yogurt, 200 pounds, like that. So now I think my results are kind of over the top, but ladies don't gain as much as guys do. And if you were more muscular when you were younger, if you were a track person or lifted weights or did physical work, you'll gain more muscle, I believe. I think that's what we're seeing. But you want muscle. So you've heard of a condition called sarcopenia, right? Loss of muscle, and you lose independence. You can't climb stairs. You have to use a motorized cart at the grocery store. You're more prone to falls, fractures, and early death. So losing muscle is very bad. By the way, so one thing to be aware of, as we age, about a third of our muscle is lost just from the process of aging. And if you lost weight by following a low-calorie diet, a stupid GLP-1 agonist drug, or a bariatric procedure, you lost a huge amount of muscle and you've hastened your death. How can you rebuild muscle? Lactobacillus reuteri, collagen peptides. So collagen is not just good for joints and skin, it's also good for remodeling your body, reduction of abdominal visceral fat, and increase in lean muscle mass. Likewise, carotenoids, whether it's lycopene, lutein, zeaxanthin, or my favorite, astaxanthin, also helps remodel your body. So my book coming out in December, it's got a stupid name because my publisher wouldn't let me use the title I wanted to use, which was Bulge, the New Science of Shape and Body Composition. They made me call it Super Body. But it's a book.
So are you going to have a picture in a little Superman outfit on the front?
It makes me think supermodel. I had such big battles with these people. But anyway, so it's going to be called Super Body, stupidly. But it's a book about shape and body composition, regaining youthful musculature to gain all the advantage that provides, reversing age-related loss, as well as the mistakes you may have made in cutting calories in some fashion past, while also minimizing abdominal visceral fat. So, in other words, it's the next step beyond just lose weight. Losing weight's dumb. You don't want to lose weight. That's dumb. You want to maintain or increase or preserve muscle and lose abdominal visceral fat specifically. You can lose other fat forms, but that will follow. The most problematic source of fat is the abdominal visceral fat that encircles the abdomen. How'd we get on that?
I don't know.
Oh,
so
weight gain.
Yeah, weight gain. Okay, so Maha's question was if we could use the HU58, which is a Bacillus subtilis, to ferment juice. So I think, it should ferment like the DE111, I would expect. Wouldn't you, Bill?
What I don't know, Maha, is whether it's going to carbonate for you. I was looking for carbonation.
Can you hear me, Dr.
Yes, we can hear you.
Oh, cool. So I tried the non-kombucha with juice. I let it ferment for like 90 hours, and the sugar disappeared. There's a little bit of bubbles, but I'm not crazy about this process. It's too time consuming. So what I wonder is if I just keep it on the countertop, it probably won't be 90 degrees, but if I leave it longer with HU58 instead of this kombucha thing that I don't know if it really has like the microbe I wanted to have, will that work? And I'm happy to experience and let you know, but have you experienced with that?
No, sorry, Ma, I have not. So I don't know. You can try, if you're worried about, always think about run test batches. Don't use a whole big thing, right? Use a little, maybe a half a cup of juice and a little bit of whatever your source is. And then do as you ordinarily would. And if it doesn't work, you're just going to throw away that whatever, half cup, 1 cup, rather than a whole, liter or two.
Right.
Run a test batch.
Good idea.
So I use this kefir juice, like fizzy fermented juice starter from it's from Cutting Edge Cultures, but I get it from Cultured Food Life, and it has the Saccharomyces boulardii that you're asking about, Maha. It has Leuconostoc mesenteroides. I know because they buy the strain from us that goes in here, and that's in our sugar shift, and that basically is what makes your gut anaerobic, just like it does in sauerkraut. It makes the environment anaerobic. It has Lactobacillus delbrueckii. That's a classic yogurt strain, but also, a great immune bug as well. And then it has bifidolongum. So, if you're looking for a simple way to do it, like you put this,
I'm very successful with the boulardii. I'm never missing a batch. So I enjoy making it. I just want to find a way to make it that is easier. And
yeah, so this is easy. You sit it on the counter for 2 days and then stick it in the refrigerator.
All right.
You don't have to heat it up or do it. Like, you don't have to do anything fancy. It's very simple.
I think Ma's having more trouble with the Bacillus subtilis.
Yes.
Yeah.
Yes. And the other thing is, can you mix the boulardii and the subtilis, Bacillus subtilis? Or have them at the same time? Not necessarily mix them in the same pot, but eat them at the same time.
I expect they would work pretty well together. Just from what I know about the systems that we've put together, I think they would probably be fine together. Bacillus subtilis is a very interesting organism. It's also one of the few organisms, if it doesn't have enough food, it splits the colony in half and sacrifices half the colony to feed itself instead of eating you or somebody else. So it is a really interesting organism from how it works and all the things that it makes and does. And it was interesting in the very beginning when we were developing Sugar Shift for my husband, John, and I was working with my friend Steve, who was a fermentation chemist, and we had come up with this formula together, and he was having trouble finding Bacillus subtilis, and he's like, "Does it really need to have Bacillus subtilis?" And I said, "I can't tell you why today, but yes, it has to have Bacillus subtilis." And that has turned out, after we built our models and we were able to look at it, when we pulled the Bacillus subtilis out, it affected the butyrate metabolism of the other organisms. It affected the whole ecosystem. And I think maybe it's the one that holds the balance of the orchestra together. So it's a very, and I think it has some detoxification capabilities, and and it certainly keeps down the bad gas. So
Excellent. Well, that's encouraging. Thank you so much. Good to see you, Dr. Davis. I miss you on Wednesday night, but it's a bit late for me. So I was happy to see you tonight.
Same here, Maha.
Lovely. Thank you, Martha.
okay. Okay, do I have another HU? I have used HU58 and DE111 bacillus both in juice and yogurt. I take both. And S. boulardii cider a couple times a week. I consume chicken soup regularly with the carcass of my roast chickens, but only boil for about an hour or two to minimize heavy metal extraction. Well, if you take the bean minerals, the humic fulvic minerals can help eliminate those heavy metals. So then you can have your thick collagen broth and get rid of the heavy metals. That would be, so I don't know if that was really a question. That's more of a statement. John Sassmore has his hand up. So, and then I have a question from Charlie.
Hi, two questions. First one is, how do we know if we've eaten too many microbes in these fermented foods? And where's the point where the microbes are going to start eating us?
I think it's hard, John, to overdo it, just because Martha will tell you there's hundreds of trillions of microbes in your GI tract, and so you probably have to make it a career to get promoted. I've taken a trillion of rotari and had no adverse effect. Now, the only time I've seen overproliferation, of course, it was dysbiosis. That's an example of overproliferation of fecal species like E. coli and Klebsiella. SIBO, of course, is likewise an overproliferation of fecal microbes. I think you're talking about kind of the microbes regarded as friendly, like Fecalibacterium acromancy and Lactobacillus. The only time I've seen where that happens is ketogenic and carnivorous diets. So those people who, there's as many forms of these diets as there are people who talk about it, right? But one of the mistakes they make is the failure to include fibers to nourish microbes. So if you want to be a ketogenic diet, I go keto, right? And you fail to get vegetables that provide plant matter like fibers. One of the things that happens is that Akkermansia loves fibers. And when it gets fibers, it's perfectly happy. And it stays to comprise somewhere around 4 to 5% of your entire GI microbiome. When you deprive Akkermansia of fiber, it has this added capacity to consume human mucus. That's why its full name is Akkermansia mucinophila, mucus lover. And so Akkermansia will overproliferate, sometimes to bizarre degrees, 18%, 36% of your entire microbiome, and it's eating your human mucus. And that leads to colitis, intestinal inflammation, an increase in permeability, and thereby endotoxemia. And that's why I believe people who did Atkins years ago or ketogenic or carnivorous diets, now they say, oh, I lost 43 pounds, my waist shrunk by 8 inches, my triglycerides dropped from 350 to 48, my HDL went up from 42 to 83, my blood glucose dropped from pre-diabetic to normal, 88. So all these upfront benefits. Then about 18 months or so into it, they say, I'm regaining weight. My triglycerides are back up to 280. My blood glucose went back up to the pre-diabetic range. I'm now hypertensive. In other words, all the initial effects that derive from the change in diet now reverse. And I believe we need more evidence, but that's likely due to the overproliferation of Akkermansia. That's the only situation that comes to mind for me. You know of any other situations, Martha?
Well, it's interesting because people with Parkinson's and MS have elevated Akkermansia. And I do think like part of the issue is, so when you go on a carnivore or strict ketogenic diet, you starve a lot of the LPS producing bacteria. So you do get a die off that happens. But what also happens is your body loses its ability to deal with glucose. And so you have a metabolic swing the other way. And you've lost a lot of the microbes that deal with those carbohydrates. So I think you're very much correct that, while it can solve some problems with inflammation and things that people have, and that's why people get such great results from it, is because it has remodeled the microbiome. But then you can't do that long term, I'll say. So I did keto and I did a lot of fasting and lost a bunch of weight, but what I found was it wasn't working for me anymore, and my blood sugar was rising. And I'm like, so then I ended up finding the glucose 101 thing, and that I'm trying it right now. And TBD, but what I can say is the other people that I know who are trying it they have better ways to see if it's working, because I don't have any health issues. But if you have health issues, you start to see those reversing. And I think there's definitely something to, and that glucose for me is feeding the red blood cells. So you're feeding the red blood cells and you're feeding the brain. And then we've got to feed the microbes, that, fiber you're talking about. And we've got to, do the hyaluronic acid and the things that are feeding that glycocalyx. So,
now, John, there's also an overproliferation of hydrogen sulfide producing species like D. sulfovibrio and
H. pylori.
Oh, H. pylori. I was thinking more along the lines of it's another hydrogen sulfide producing species. It'll come to me. Those are believed to be causes of colon cancer. So, please don't hear red meat causes colon cancer. Please don't hear that. That's nonsense. But in this case, it's failure to obtain fibers may cause a proliferation of hydrogen sulfide producing species, which in turn may be a risk factor for colon cancer.
So
by the
there
way,
are also elevated hydrogen sulfide producers in Parkinson's,
Mm.
and that is one of the microbes that we're writing about in our paper. Is a urease producer. This is H. pylori. So you have elevated hydrogen sulfide. You also have elevated methane, but hydrogen sulfide is also a free radical scavenger. So it's like, again, Goldilocks. We want Goldilocks. And we've done all these crazy food things, like swinging ourselves all over the place. And, we're not Goldilocks right now in kind of the whole arena of, what we're talking about. I have another question about light. So since we're talking about light and frequency here, what's your opinion on the blue light blocking glasses? Are they beneficial for people who are exposed to light from tech devices and LEDs all day, or are they overhyped?
The science has matured in just in the last few years. And as you mentioned earlier, blue light has been. So there's a study where they took a whole bunch of lenses out of pigs and put them into a saline bath, and exposed them to blue for 24 hours. And every last lens developed cataracts. So that's pretty solid. The evidence that blue light contributes to macular degeneration is a little iffy, tough thing to prove, but it seems to have a modest effect in the earlier phases of the disease. Now, it is clear that blue does reduce visual acuity. Now, how temporary or how permanent that is, to me, is not clear, but it is clear that it's kind of like the low saturated fat, low cholesterol advice. They gave us that advice, and then we watch disaster, right? We learn, well, most have not learned from this, but we have learned from that mistake. In other words, they made a huge blunder, and then we saw that it was wrong. I think the same thing here. We converted to blue LEDs for the sake of reducing energy costs, a good thing, not recognizing that overexposure to blue through all times of the day is very detrimental. It also causes you to gain weight, specifically in abdominal fat, and increases your insulin resistance. It's not a big effect, but if you don't need it. So wearing blue blockers, or the kind that Jen is wearing, which is even more effective in blocking blue. I can tell Martha's wearing blue blocks. I can see blue in her lenses. It's reflecting blue, right? Though it is a good idea. And you probably don't want to replace all your LED blues in your house, because now your energy costs are going to go way up. So I'll tell you what I do is just replace where you work a lot or where you use a lot of light. Maybe a chair where you read a lot, or in my case, my desk. I have a desk lamp here. So these are 2 incandescent lamps. And personally, it made a world of difference within 48. It was so quick like that. All my vision normalized within 48 hours. I don't know if you'll have that, but I think it's unrealistic to convert all your LED blues back to incandescent. Fluorescent, by the way, is also blue and white. So you want to try to avoid those 2.
That, they were on this trajectory to get rid of all the incandescent bulbs by 2026, I think, and they've actually reversed that. So I think you are still going to be able to get incandescent bulbs, which is nice. And there are some full spectrum. So somebody I was talking to was talking about the full spectrum lizard light. Did we talk about that on here? Maybe not. So it was this other podcast I did today. So, I was trying to change out the lights around here, and I sit in a chair and read. And so I was looking for, some type of a reddish light. And so my son, Charlie, and I went to the pet store, and we went to the lizard section, and we got like a full spectrum lizard light, and then a red lizard light, and a couple other things that I don't even know where I put those. But we get up to the counter, and the young woman who's checking us out says, what kind of lizard do you have? And Charlie looks at me and said, she's the lizard. I loved it. But so then today I was on this other podcast, and I was talking to him, and we started talking about light, and he's doing podcasts a lot. So he's cut down so that he's only on video 2 days a week. But he held it up, and it was like one of those like that you have in a car studio or whatever, that the light bulb's in there and you can hang it anywhere. And he said, this is my full spectrum lizard light. I was like, he said they figured it out. They knew it had an impact on lizards, so they must know it has an impact on us. I think
I had a funny experience recently too. I was stopping at some brew making supply stores, and of course I'm looking at their microbes and their fermenting equipment. And he says, what are you interested in? I said, fermenting equipment. He says, what are you fermenting? I said, human microbes. And he's like, what? You're doing what? It struck me what we're doing. We're fermenting human microbes.
Yeah. Because we're more microbial than we are human. And I think John had one more question, and I think that's the last of our questions, unless anybody else wants to pipe in here.
So I've been fermenting these cooked vegetables, and occasionally some batch will get too acidic, and it even gets too acidic, it'll burn my teeth. So what I started doing was adding a little bit of baking soda. So the baking soda is sodium bicarbonate. The bicarbonate will react to the acid and makes CO2. So I was thinking about this when there's the fizzy sparkling juice. But when I do this, it just tastes great. And I wonder if there's a benefit from that carbon dioxide that gets trapped in it. But my question is, have I killed the microbes, or how far can the pH go up before the microbes aren't happy anymore?
So I will tell you, Dr. Nenham, the researcher that I'm working on this Parkinson's paper with. So there's a guy named Mark Adams who did a study in the 1950s, I think. If I can probably go find the paper and post it in the chat with this when we post the video, but he basically showed that agitating water and making nanobubbles kills all bacteria and viruses. And CO2, so they make like CO2 bubbles, breaks the cell walls up. And so in the body and in the glycocalyx, part of what's preserving and keeping the microbes out is the CO2 nanobubbles. So I don't know if it killed it probably killed some of your bugs. I'll just say that.
You'd probably have to submit it for formal analysis, John.
Yeah.
Not an easy thing to do.
No, and when you have multiple microbes, it's like Bill, you have such a super fan club, and you talk about bacterial counts, and so people are always asking me, so like if I ferment the sugar shift for this many hours at this temperature, how many CFUs am I going to have? And it's like, this is a complex group of microbes growing over a period of time. It's probably going to be different every single time. And the only way to do that is to, or I had one person want to know how much CFUs of each individual microbe. I'm like, if I told you the computational power it would take to figure that out, it would take that new Majorana chip to figure it out, because of the complexity of how that all works out. So anyway,
impractical. You'd have the DNA sequence each and every one, and then run flow cytometry. It'd be probably a couple of $1,000 each for each batch.
Oh, so maybe more than that, because you've also got to separate out you can't actually really you'd have to do flow cytometry, but it wouldn't tell you the individual microbes. So we actually do flow cytometry on every batch of sugar shift before we send it out, or before it goes into the capsules. And like most people don't do that. They do plate counts, which aren't very accurate, but flow cytometry will tell you how many live microbes you have, how many injured microbes you have, and how many dead bugs you have. And, one of the big myths that I hear in the sales pitch these days is, oh, I've got my probiotics, the only one that's got prebiotics, probiotics, and postbiotics. And I just want to say that that's a bunch of hooey, because every single strain microbe, when it is grown in pure culture, it is grown in prebiotics. And the live bacteria are the probiotics. And as they're growing, they produce secondary metabolites, which are postbiotics. And then at the end, they take all of that and they freeze dry it. And you have what's left of the prebiotics, you have the probiotics, and you have the postbiotics. So people who are pitching you that they have the only formula that has all of those, they're lying to you. It's a marketing spin. Anyway, that's my I have a soapbox about that. It's like, really? Well, do we have any more questions from anyone? It looks like we're wrapping it up here. So I really, we so love having you, Bill. Like I'd have you,
Martha.
All the time, because so much. You're just so exciting and fun. Your research is amazing, and you're one of the few clinicians that I've ever run across who really understands the microbiome.
Thank you, Martha. Nice to hear. And keep on doing what you're doing. You're doing fantastic things. And thanks, everybody. New faces, familiar faces. Everyone have a good night.
Thanks, Bill.
Take care.
Thanks so much.
Thank you, Martha.
Thank you.
Thank you.
We'll see you in 2 weeks. And I can't remember who. Oh, Petra is going to be here in 2 weeks. So we'll have Petra in 2 weeks.
Thanks, Martha. Appreciate it.
Thanks, Dave.